So we are given the root of a boundary tree. We need to return the maximum average value of a subtree of that tree, and the answer will be within 10 to the power of minus 5. And a subtree of a tree is any node of that tree plus all its descendants. It means, for example, this node 5, any node, and plus all its descendants plus 6 and 1, and we got an average. It is 4, and then we got 6, and there's no descendants, so the average would be 6, and another one is 1. So the maximum is gonna be 6, so we're gonna return 6 within 10 to the power of minus 5. Yeah, so this is a typical tree problem, and we're gonna use the DFS to solve it. And if you can recognize the pattern, it's gonna be a post-order traversal. So in tree, there are 3 traversals, and the most often used is post-order traversal. Why we can use post-order traversal to solve it? So, for example, if this is a so for the post-order traversal, it always go to the left and right and then the root. So we first go to the left side. We got a 6, and we get the result. It is a 6. And then we go to the right. We got a 1, and we get a 1. So the result currently maximum is 6. And then we go to the root node. So for that, it's gonna be 3, because there are 3 nodes, and the sum of them will be 12. 12 divided by 3, it is 4. But our maximum value is 6, so we're gonna return 6. So this is why we're gonna use the post-order traversal to solve the problem. Yeah. If you are familiar with post-order traversal, normally you can solve it easily. So let's just write a post-order traversal. So we're gonna traverse it from the node. It's a DFS. Yeah, so we're gonna design it like this. So for me, I would like to define the left number. It means how many nodes at the left side, and I also prepare a left value. Yeah, so this will be my DFS not dot left. So this is just my design. You can also design like yours, but you need to familiar with the recursive function. So now I'm gonna prepare the right num and right value. So it's gonna be the DFS not dot right. I suggest you need to use a pattern. Maybe you're gonna use this pattern. Yeah, I prefer to use this pattern because I think it is easier to recognize and it's easier to write, and the logic is very clear. So we got the left number and the left value, right number and right value. Yeah, you may be confused why you can get that. Yeah, because I'm gonna design it later. While I'm writing this, I know how to design it like this because I'm gonna have a return. I'm gonna design my return value. Yeah. So for example, if there's no node at the left side, what I gonna return? So if not node, so I'm gonna return 2 values. 0, it means there's a 0 node, and another 0, it means the value of the left side or the right side, it is 0. So this is my design. If the node is none, I'm gonna return 0. It means 0 node and 0 value. This 0 means the sum of them, sum of all the values. Yeah. Now, what my function gonna return? So for example, at 6, at the left side it is 0, 0. The right side it is also 0, 0. But how can I get the value, the node, and sum of them, the value at the this node, at this node 6. So I'm gonna return something. It's gonna be left num plus the right num because I'm not sure. So for example, at node 6 there's a left num and right num. Also similarly for node 5, I'm gonna return the left num plus the right num. Yeah. Plus a 1. Because for node 5, the left side and the right side I should plus itself. So I'm gonna plus a 1. And similarly for the values, it should be the same. So the left val plus right val and plus the value itself, so not dot value. So this is my return. Yeah, but this return is just for the root node itself. If I'm going to calculate the root node, it is okay, but I'm going to check all the possible results, but this possible result is 6. Yeah, so this means I'm gonna record the result in between the DFS. Normally at this position, I'm gonna record the result. Yeah, so I'm gonna prepare a variable self.result would be equal to 0. Then I'm gonna execute the DFS with the root node. After that, I'm gonna return the self.result. Yeah. From here, I'm going to design self.result. So self.result would be the maximum of self.result. Yeah. With what? I just need to copy the line. Yeah, because the final result would be this one. Yeah, would be this value. And divided by this value. Yeah, here. Yeah, so this is gonna be the final result. It is the maximum of all the possible results. Yeah, and now we've already designed the DFS. It is a post-order traversal. First of all, you're gonna left, and then right, and then you're gonna go to the root node. So this is exactly the post-order traversal, and the code is really concise and simple. Now let me run it. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. As you can see, it passed all the testing cases, and the time complexity is ON. N is 10 to the power of 4 because this is a traversal problem. You just need to traverse all the nodes, and you don't need to use 2 loops, just 1 loop. Yeah. So this is the this is why we're gonna use the post-order traversal to solve a lot of Leetcode problem and even the hard problem. The post-order traversal is like a tree DP problem. So most of the tree DP problem will be solved by post-order traversal. So while we are traversing the node, actually we've already got the result. So we're gonna choose the maximum of all the possible results. So I think this question is gonna be a really good question. If you have the chance to practice this question, yeah. So please learn the post-order traversal and use the post-order traversal as a tree DP problem to solve all the similar problems. Thank you for watching. See you next time.